All right, today we're going to talk about a piece of equipment that you've probably walked past 1,000 times and never even noticed. But here's the thing, it's a silent guardian, an unsung hero that is absolutely critical when things go wrong in a fire.
So just imagine this for a second. There's a fire breaking out on the 40th floor of a skyscraper. Firefighters need a massive amount of water, and they need it right now. But just as important, they need to be able to shut it off or maybe isolate one section for a repair, all while managing these incredible pressures. So how do you do that? How do you possibly tame that much raw power? Well, the answer is this pretty unassuming device, the firefighting gate valve. At its core, it's really just an incredibly tough on-off switch. Its job isn't to kind of sorta reduce the flow, no. Its job is to either let water blast through at full force or to shut it off completely with a perfect leak-proof seal. So here's what we're going to cover. First, we'll talk about why these things are so important. Then we'll meet the different types, see where they're used in the real world, and even compare them to another kind of valve. And finally, we'll get into the super strict rules that make sure they never, ever fail.
Okay, so let's really focus on that core problem. Think about a building's fire protection system, with all its sprinklers and standpipes. It's just a huge, complex network of pipes, all filled with high-pressure water. Now, if you don't have a way to shut off certain sections, a single leak or a simple maintenance job would mean you'd have to drain the entire system, leaving the whole building completely unprotected.
So the mission for this little device is crystal clear, and it has two parts. When it's open, it has to be fully open, creating a totally clear path for the water, no obstructions. But when it's closed, it has to create what engineers call a bubble-tight seal. I mean, there's absolutely no room for error here. It's all or nothing.
Right, so as you might guess, this isn't a one-size-fits-all kind of deal. Not all gate valves are the same. They're actually specialized tools designed for different jobs. So let's meet the key players in the valve family. First up, we've got the OS&Y valve. Now, the name sounds kind of complicated, right? Outside screw and yoke. But its design is pure genius. When you turn the handle, that threaded rod in the middle, the stem, either rises up or lowers down. This gives you an instant visual confirmation. If the stem is up, the valve's open. If the stem is down, it's closed. Simple. You'll find these all over the place in pump rooms, where that kind of clarity is absolutely essential.
And then you have its sneaky cousin, the NRS, or non-rising stem valve. With this one, the stem stays put. It doesn't move up or down. That makes the whole valve way more compact, which is perfect for jamming into tight spaces or for burying underground with the water mains. And since you can't see the stem, it's usually hooked up to a post indicator above ground that tells you if it's open or closed.
Okay, but how do they get that bubble-tight seal we were talking about? Well, this is where the technology gets really cool. Most modern valves are what we call resilient seated. Inside, there's a heavy iron wedge, but it's completely wrapped in this super tough rubber. So when the valve closes, that rubber wedge presses firmly against the valve body and creates a perfect, compressed, totally leak-proof seal. Not even a single drop can get through. And of course, you've got your specialists for the really tough jobs. Metal-seated valves, for example, use a metal-on-metal seal, which you need for really extreme high-pressure or high-temperature situations. And then there are grooved valves, which have these special ends that let you connect pipes way faster, saving a ton of time during installation. All right, so we've met the whole valve family, but where do these things actually live? Let's take a look at where you'd find them working inside a building's safety network. You'll find them at all these critical control points. They're used to isolate different zones in a sprinkler system, so you can do maintenance on one floor without shutting off the whole building. They're the main shutoff for fire hydrant lines out on the street. They control the massive pipes, the suction and discharge lines that feed the fire pumps. And they are absolutely crucial for standpipe systems. The vertical water mains that run all the way up a skyscraper. Now, you might be wondering, okay, is the gate valve the only game in town for controlling water flow? And the answer is no, it's not. There's another major player called the butterfly valve, and deciding which one to use is a really important choice. So, when you've got a couple of options, how do you pick the right one? Well, it all comes down to their basic design and what you need them to do. And this chart here breaks it down perfectly. See, the gate valve gives you a full, wide-open path for the water, which means almost zero flow restriction. That's why it's the undisputed champ for a main shutoff. A butterfly valve, on the other hand, always has a little disc sitting in the middle of the water path, which creates some turbulence. But it's way smaller, and you can open or close it with just a quick quarter turn, which makes it great for smaller zone shutoffs. Okay, so we've got the right valve in the right spot. But how do we know? I mean, how can we be absolutely 100% certain that it's going to work when a fire finally breaks out, maybe decades from now? Well, that all comes down to playing by a very, very strict set of rules. And honestly, this is the most important part. A fire protection system isn't just plumbing, it's an engineered life safety system. Every single component has to be rigorously tested and certified to perform under the worst possible conditions. Because failure isn't just a little leak, failure could mean no water on that 40th floor, turning a bad situation into an absolute catastrophe. Failure is simply not an option. And this right here is the safety playbook. All these acronyms, UL, FM, NFPA, they represent a global agreement on what makes a valve safe and reliable. You have independent labs like UL and FM that test and certify the equipment. You have organizations like the NFPA that write the rulebooks for how fire systems should be designed and maintained. They dictate everything from the exact metals and rubbers used to the pressures they have to withstand. And then local codes make sure these global standards are enforced everywhere. And all of this trust is backed by a whole global ecosystem of amazing manufacturers. Companies all over the world pour huge amounts of money and brainpower into engineering and testing their products just to meet and exceed these incredibly high standards, all to make sure that every single valve that gets installed is ready for duty. So when you boil it all down, that's what these things are. They're not flashy. They spend their entire lives hidden behind a wall or buried under a street. But they are the silent, totally reliable guardians that make sure when we need water to save lives, it is there, and it is completely under our control. So the next time you're walking through an office building or a hotel and you happen to glance up and see a fire sprinkler, maybe you'll think about that hidden gatekeeper, that simple, powerful gate valve somewhere deep in the walls, just standing by ready to do its job.